yi also knows. So now if we want to, in this single regression model, if we want to introduce Zi, in a real experiment, Zi has to be some element or some factor which has co-movement with yi also and xi also. So
we just to have co-movement with xi. We just want that.
But the formula, if we take beta.
Yeah, so numerator here obviously is Zi, so you need to have covariance co-movement with y and z.
So now in a real world experiment, if we go to see, in the first place, if we take Zi as a separate element and make it two-variable regression model, wouldn't that be anyway solving this problem? That is first question.
No.
And the second is
Why? So okay. Let's first debate his question. He says, so if you write a model, instead of putting an instrumental variables, you still work with an OLS model, but write a model where y is equal to alpha plus beta 1 xi plus beta 2 zi plus ei. Will that solve the problem? Will that not solve the problem? Yeah, but xi will still continue to be correlated with ei, no? Yeah, so beta 1 will still be, in fact, all the variables will still be inconsistent, because if you have a multiple regression model, then you have to solve condition summation xi ei is equal to 0, summation zi ei is equal to 0. So you will not have two conditions in two unknowns, or three conditions in three unknowns if you have an alpha, summation ei is equal to 0. So if summation xi ei is not equal to 0, you don't have enough equations to solve for the three. So whatever you get, so that problem will continue to be there.
So but now if we got the Zi in our equation, then we take the covariance Zi ei is equal to 0, assuming that covariance xi ei and xi Zi is not equal to 0. But how will we in a real world model find a variable which we have not overlooked anything? How will we find a new variable which is related with xi every time?
That's why instrumental variables are difficult to find. Right? But let me give you an example of how economic theory tells you how you will find variables. See, please remember, the basis of all econometrics continues to be economic theory, because it tells you what variables to include, what variables to exclude, what variables should act as instrumental variables, and so on. So without having a good theoretical model, you never can really do any useful econometrics. And this will be one example of that. Right? So please remember, what you learn in micro, macro is the foundation of the kind of econometric models that you are going to do. Yeah? I'll quickly tell you one example, but before that, so suppose now I have a demand supply. Suppose I want to estimate a demand. Yeah? So I have, say, quantity is alpha 1 plus beta 1 pi plus ei, and I expect beta 1 to be less than 0. Why do I expect beta 1 to be less than 0? Qi is a quantity demanded. So I will write this QID. Okay? I have a quantity supply is some other error term here, right? And you would expect beta 2 to be, yeah? Alright. Now remember, as they specified, these models are impossible to estimate. Because what is QID? Quantity demanded. What is the quantity demanded? The quantity demanded is something, is a plan that people have in their minds. So we are trying to get the points along the demand curve. What is the demand curve? Does the demand curve anywhere exist physically? Can you see a demand curve ever? You can't. Because these are all plans in people's minds. They say price is this much, I'll buy these many mangoes, if price falls, then I'll buy more mangoes, right? If price falls more, so if for example iPhone 7s is very expensive now, if the price falls, then I'll buy one iPhone S7, if price falls even more, I'll buy many more, and it becomes available for 100 rupees, there are lots of them I will buy, alright? Okay, but I can never go to a market and really find out this empirical relationship because this is all in my head. Similarly for the supply. So you can never get data on the demand curve and the supply. So what are the points that you can observe? The only points you can observe in the market is where transactions are actually happening. Here you go to the market and say what is the price for which iPhones are selling and how many iPhones have already been sold. Right? So what are the points that you observe in the market? The points at which the market is clear. The points which are on the demand curve as well as the supply. The intersection point is what I observe in the market. Now, do you see a problem with this? If I have a problem, I am only going to observe data where of the points of the intersection of demand and supply curve, then one of my variables is quantity, the other is my price. And is price an exogenous variable here? In a demand supply interaction system, is price an exogenous variable or is price determined by the demand and supply? So quantity demanded is determined by price and price is determined by quantity demanded. So I don't have an exogeneity problem. In fact, an endogeneity problem because I do not have exogeneity. Right? So I will not be able to estimate alpha 1, beta 1, alpha 2, beta 2 if I did the OLS regression. You see this is a very fundamental problem. Right? Okay? So how do I, so I'll simplify it. Okay, what I'll do is, I'll first try. So let me do one thing. Let me write, so I have QID. So what will I see in the market? QID is equal to QIS are the points that I will see. Right? So, in the market, actually, what I'll observe is all those points yeah? Sure? Now, from which it follows clearly that alpha 1 minus alpha 2 PI minus VI right? Don't copy down. Right? This is very simple. I'm just shifting variables from here and there. No? Right? So, I actually have PI You see the problem, friends? So PI now depends upon EI as well as VI. Right? And similarly, QI will also depend upon EI and VI. This is called the reduced form, where I've got all the endogenous variables on one side and all the exogenous variables on the other side. So what I've done is, I've written the price equation in a reduced form. I've written the price equation in a reduced form. The moment I write it in a reduced form, what do I get? I see clearly that PI depends upon EI as well as VI. You see how? PI clearly depends upon EI. PI clearly depends upon VI. Right? If PI depends upon EI and VI, neither here nor here are the correlations between PI and EI and PI and VI is 0. Which means that I can neither estimate a demand curve and the supply curve independently. Right? I can estimate neither demand curve or the supply curve in it. But now, suppose I say that actually, when I have, so think of a variable, yi. So I know that quantity depends upon price, but quantity also depends upon income. That's what economic theory tells me. Right? Quantity depends upon price, but quantity also depends upon income. So I will write here gamma yi plus pi. Okay? And suppose quantity supplied is the quantity supplied of onions. So we know that quantity supplied of onions depends upon rainfall. If it rains a lot, then onions spoil and you don't get enough onions in the market. Or let's call it green vegetables. Right? So if you have bad rainfall, then obviously you don't get a lot of green vegetables in the market. Right? Or call it mangoes and say rainfall before the season. So if it rains heavily before the mango season, then obviously the supply of mangoes in the market goes down. So let me now write this as plus pi plus say Ri plus right? Now, if I now write this, okay, at the moment, suppose we are not just doing this, we are just putting it. At the moment, just think of this. Okay? So now, if I do the exercise that I have done, now if I use the exercise that I have done, what do I get? I will get yeah. So I have here, alpha 1 minus alpha 2, alright, plus pi minus is equal to gamma yi plus right? Or beta 1 minus beta 2.
So that should be minus gamma y. And then on this side, it should so the one above, it should be minus when it's on RHS and plus when it's on LHS.
Yeah? And it should be beta 1 minus beta 2.
Beta 2 minus beta.
Beta 2 is equal to pi. Now what does this clearly show? It shows that yi is correlated with pi. Yeah? yi is correlated with pi. Does it not show that? Okay. Now the question is whether yi is correlated with ei or vi. Whether yi is correlated with ei or vi. Right. So let me write the equation for yi. Okay, let me write the equation for y. Right? So you clearly see here that yi, okay, this is something for you to think about it. So you will bridge that gap. You can see clearly that yi is correlated with pi. Yeah? But yi is not a function, not dependent upon vi. Because what is vi? Vi is the supply shock to mangoes. VI is the supply shock to mangoes. YI is the income of the consumers in Mumbai. So YI and PVI are not related, right? But YI and PI are correlated. So YI can be an instrument to estimate beta alpha 2 and beta 2. YI can be an instrument to estimate alpha 2 and beta. Right? By the same logic, if I put rainfall here, then I can show that the rainfall is correlated with PI. But this is what? This is shocks to the demand curve. And the rainfall in Ratnagiri is not correlated with the demand shocks in Mumbai. So you will have an RI variable which is correlated with PI, which can be used as an instrument for alpha 1, beta 1 and gamma. Right? Alpha 1, beta 1 and gamma. So what we have done is we have separately identified the demand and curve and supply curve, because now we will know what is alpha 1, beta 1. So we can identify the demand curve. We know what is alpha 2, beta 2, we can identify the supply curve. What we have done is, we have used the instrumental variables to separately identify the demand and the supply curves. Okay, you have a question? So is this idea clear? So basically on the basis of economic theory, we have said there are some factors which move the supply curve. So there is essentially what we have done is, we have included a variable in the supply equation which is excluded from the demand equation, which helps us to identify the demand curve. There is an equation which is included in the demand in the supply curve, not include the demand curve, which helps us identify the demand curve. We have put a variable in the demand curve which is not there in the supply curve, the YI, which helps us identify the supply curve. Right? These conditions of course have a name. These are called rank conditions and order conditions, but we will come to that later. So basically you can use instrumental, for example, if there are simultaneous equations, then you can use economic theory to think about creating instrumental variables estimators, because the OLS estimators will not work. Okay, OLS estimators will not work. Right? Y is the instrumental variable for identifying the supply curve. And if I put a rainfall variable here in the supply model, then that is the instrumental variable to identify the demand curve. Yeah? See, because I can't use YI to identify the demand curve, because YI could be correlated with EI, no? How do I know that that income movements in Mumbai are not correlated with the error term? They can be. But I know for sure that the income movements in Mumbai are not correlated with the rainfall shocks or the supply shocks in the mangoes in Ratnagiri. So I can use that to identify the demand curve. And similarly I can add. So whenever you are developing a model for demand and supply curves, for example, the instrumental variables idea becomes a very critical idea, because the problem is essentially that of endogeneity, and whenever there is endogeneity, that is covariance x and y is not 0, the correct methods to use is not the OLS but the instrumental variable. So what will be the instrumental variable for beta 1? So for example beta hat 2, the instrumental variable for beta hat 2 will be very simply summation Pi minus P bar, summation, no, Qi minus Q bar, right? So it has to be covariance xz, covariance yz, right? So it has to be this is instrumental variable for beta hat 2. Pardon? Where? Beta hat 2, we are using y as an instrument for finding beta hat 2. So what is the estimator there? Covariance xz, covariance yz upon covariance xz. So what is covariance yz here? y is here and qi. So summation qi minus q bar, yi minus y bar upon pi minus p bar upon yi minus y bar. That would be an estimator for beta hat 2. It's so simple, no? But this estimator will be a consistent estimate. Unlike if you did just a linear regression, it might not be a consistent estimate. You see the point? Just remember this beautiful idea of law of large number. You'll be able to find your own estimators or your own. So if now let me test your understanding. If I put a theta Ri plus Vi here, yeah? So how will I get an estimator IV? Beta 2 IV. How will I get beta 1 hat IV? How will I get beta 1 hat IV? Summation qi minus q bar Ri minus R bar upon you got the beta hat 2 estimations. It's so simple. Now you guys can construct your own estimate. That's why you understand both econometric theory. Computers can never do that. So you have to think of it. Sure? Okay folks, so I think we will stop here today. I didn't intend to do this, but because this gentleman got this computer here, I did this. But I don't want to pressurize you immediately after your class, after your exam. And you also have, some of you also have some interviews to give for the less than class. So please go for this. So that you can go for these interviews, we will stop. Are there any difficulties? Applied science.
So beta hat 1 IV shows that covariance QR
covariance of y and z. So what is z? Z is R.
So covariance of range and quantity. Covariance of
Price and range. Sure? So next class I am going to ask you to construct some of your own estimators for problems. Yeah? So see you folks. Have you shut this off?